Hello, David Harper of the Bionic Turtle here with a brief tutorial where I'd like to answer the question, what is the square root rule? The square root rule we use often in the FRM curriculum and in the measurement of volatility and value at risk. So I'll continue to build on data that I've been building for a few days now. I pulled the stock price closes for Google last week, so I have a very short series of 5 stock prices and 5 daily rates of return. Ridiculously short. We wouldn't be this short in practice. I just want to illustrate. And previously I used the daily rates of return to compute the daily variance, and then of course I took the square root of the variance to get the daily volatility just measured over this short historical series of 5 days. Now let me go ahead and calculate the value at risk, and hopefully you recall that when I say value at risk, I need to make 2 decisions as a user, because I can't just say what's Google's value at risk based on any of this. I need to make 2 decisions. First, time horizon, and so I'm going to stick with a 1-day value at risk, and second, I need a confidence. So I'm going to say 95% confidence. And to do that, the value at risk is very simple. It's the scaled volatility, so I'm just going to take this daily volatility and multiply it by, since I'm using Excel, I'm going to rely on the normsinv function, which just takes as a parameter in this case, the confidence that I want. So I multiply volatility by normsinv of 95%. And by the way, I could put in 5% there as well. I would get the same value. It would just be a negative sign. In other words, this right here evaluates to, in this case, 1.645. If I put in a 5%, because it's based on the symmetrical normal distribution, I'm going to drag that in. Because it's based on that, at 95%, I'm going to get a value based on being out here at about 1.645. If I put in 5%, I would get negative 1.645. So it would merely be a sign change, and I would really have the same var. So I'll hit enter, and I get value at risk at 95%. In this case, is 1.8%, and again that's a daily value at risk for Google based on this assumption of volatility. So now before we answer the question, what is the square root rule, let me remind you again, we have made a distributional assumption based on historical data, and previously I showed if we took a long plot of Google's data, annual, even if we went out 3 years, that historical data is not going to be so smooth and clean and elegant as this normal distribution, which itself is so mathematically elegant that it only requires 2 parameters, a mean and a standard deviation. Neither Google's historical data nor its future pattern is going to conform so cleanly to this normal distribution. We already know that, so never forget that when we have a volatility parameter, this is a classic case of model risk in a way. Immediately as we go to use this model, which we do for the sake of convenience, we know almost immediately that we're going to be violating certain assumptions, but that doesn't mean that the model's completely broken. It just means we need to be aware of that. Okay, so knowing that we're making a distributional assumption about actual returns that are going to be messier than we would like them to be, let's go ahead and apply the square root rule. And I'm going to drag this up. It ends up being very straightforward. It's a little large here. Shrink it down. Volatility scales by the square root of time. So if we have a daily var here, let me just take this first one. If we have a daily var and we want to scale it to a weekly var, and I've got var here, but by the way, this applies to volatility. There's a linear relationship here, so I could be talking about either volatility or value at risk. If we take a daily var and want to scale it over a 5-day work week, we multiply by the square root of 5. We want to take a daily var and multiply and scale it into a monthly var based on 20 trading days. We multiply by, that's right, square root of 20. And if we want to take a daily VAR under an assumption of 250 trading days to get to an annual VAR, we multiply it by square root of 250. That's how straightforward that is, such that if I now want to convert the daily VAR that we just got, I'm going to multiply the 1.8% times the square root of 250, and let me format it into percentage terms. That's how, let me bring that formula up. That's how easy it was. I simply multiplied the daily VAR by the square root of the number of trading days in a year. There's the formula. I hit enter, and what I've got is annual VAR of 28.5%. So I went from a daily VAR to an annual VAR, and really we want to be multiplying by, I think it's a little more helpful to know that we're scaling by the delta time. This came up in the forums for last year's FRM exam, some confusion there. We're really multiplying by delta t, so that if, for example, I happen to have a 2-day VAR and I want to scale into a weekly or 5-day VAR, well then I would be multiplying by the square root of 5 divided by 2, because I'm starting in 2-day units and I'm going to 5-day units. So it's the square root of the delta t. Okay, so I'm going to move these down, and before I let you go, I got to remind you of one other really important thing about the square root rule. And here's what it is. It only works under some very rigorous, stringent assumptions. And that is, if the periodic returns are, if the return volatility is IID, or independent and identically distributed. And this turns out to be another unrealistic condition or assumption. So it's another example of where we go into the modeling exercise knowing that we're going to be breaking some of the assumptions. The square root rule really requires independent and identically distributed periodic returns. And so there's two conditions in there, independence and identical distribution, that we can violate right away. We can violate right away, well, in at least two different ways. Well, three, I think. First, if the return volatility, or the periodic returns for that matter, that's either the returns or the return volatility, if either of those exhibit mean reversion, if they are mean reverting, well, technically we violated the conditions for the use of the square root rule. And in fact, Linda Allen says in one of her assigned readings for the FRM, she asserts something that has empirically been shown. Long-run volatility for most financial asset series, like a stock, does exhibit mean reversion. So right away, technically speaking, we violated one of the conditions for the application of the square root rule. Now the other one is independence. That's one of these I's in here. That would be broken. Independence applies that the covariance between periodic returns from period to period would equal 0. So my period return today is uncorrelated with my period return tomorrow. Well, if they are correlated, there's serial or autocorrelation, and I like to kind of colloquially say that volatility is sticky. We also know empirically that to be the case. Empirically, volatility tends to be sticky and exhibit serial correlation. What do you know? We've empirically violated another assumption of the square root rule. So that's not a terrible thing. That's just a reminder that square root rule is so convenient that it requires a couple of assumptions that empirically in practice we know we violated. Okay, so I hope this was helpful on answering the question, what is the square root rule? Thanks very much for listening.